As a warm-up for this, before you go any further, why don't you pause the video here and simplify these two expressions involving exponents, and then I'll talk you through and we'll see if you did it right. So go ahead and pause it now and then start it again when you're done. So with A, we need to deal with the regular numbers, 20 over 25. That's a fraction that can be reduced to 4/5. Now we have x's on the top and we have x's on the bottom. And there's two ways of looking at this. We can do 3 minus 5, which gives us x to the negative 2, but the negative would move x squared to the bottom. I like to look at this and say, where are there more x's? There's more on the bottom. So I put x's on the bottom. And by how many more x's are there? There are 2 more down there. So this first problem simplifies to 4 over 5x squared. The second problem, there's one common mistake that happens. We've got negative 3x to the 4th times, a lot of people forget that this squared has to go to that 2 also. So it's times 4 x to the 10th. Exponent to an exponent, we multiply. Now we deal with the regular numbers like regular numbers. Negative 12 x to the 14th. This idea of squaring everything in the parentheses is a place that people commonly make the mistake and forget about the coefficient. So today is all about solving power functions and exponential functions. Here we have 9 to the x equals 27. The goal with these problems is to rewrite them so that there is a common base on both sides, so that we have a power equal to a power. 9 is the same thing as 3 squared. And 27 is the same thing as 3 cubed. I've now written both the left and right hand side using base 3. And if these two powers are indeed equal and the bases are the same, there was a property that we talked about previously that said that the exponents also have to be the same. So the 2x has to be the same as 3. I could divide by 3 on both sides. Divide by 2 on both sides. X is equal to 3/2. If you do 9 to the 3/2 in your calculator, you get 27. Now for this one thing you should notice is that 27 to the x equals a fraction. We need to figure out how can we get that to be a fraction. Well, there's going to need to be negative exponents involved for that to happen. And one way to do this problem is we can change 1 over 81 to 81 to the negative first. 81 to the negative first, if we were to simplify that, we'd write it as 1 over 81. Now we look for that common base again. 27 is 3 cubed, and then it's also to the x power, so 3 times x up in that exponent. 81 is 3 to the 4th, and then we have the negative 1 up there. 4 times negative 1, we have negative 4. Now we have two powers that are equal, same bases, so we take the exponents and equate them. X is equal to negative 4/3. The negative would flip the left-hand side into a fraction, and then 27 to the 4/3 should give us 81. getting a little bit more complex. Now we have fractions. Notice that 49 and 9 are both perfect squares. 49 is 7 squared, 9 is 3 squared. So 7/3 squared gives us that original base, so squared times x. Now notice that the bases here are reciprocals of each other. So we could involve a negative exponent, which would flip the base over. So by adding the negative in here to the 2x, that flips over the base. Now we have two powers that are equal, that have the same bases. We now equate the exponents. Negative 2x equals 3/2. Divide by negative 2. X is equal to negative 3/4. So far, we've looked at two types of equations this chapter. Exponential functions, where the variable is in the exponent, and power functions, where the variable is the base. 5.2 was all about the exponential function. It was about how do we solve when the variable's in the exponent. And the way that we have to deal with that right now is we get the same base on both sides. For the power function, we need to isolate the power and then get rid of it. So here's two examples of power functions. The variable is the base. And before we do this, I'm going to start even simpler. X squared equals 9. One way to deal with this, hopefully you're thinking square root both sides. X is equal to plus or minus 3. Now, another way to think about this is in terms purely of exponents. What can we raise this to give us an exponent of 1? What would cancel this 2 out? And the answer is the 1/2 power. 2 times 1/2 is 1. And what we do to one side, we have to do to the other. So what you need to take from this is that the 1/2 power is the same thing as the square root. And we end up with plus or minus 3 here also. If you plug in 9 to the 1/2 to your calculator, you will get 3. But fractional exponents are the same thing as roots. They will cancel out powers. So here, x to the 4th, we want to 4th root both sides. Or think about what exponent would cancel this 4th power out. We raise it to the 1/4. 4 times 1/4 is x to the 1st. 3,000 to the 1/4 is 750. I take that back. That's what people in class did. 3,000 times 1/4 is 750, but we want to do 3,000 and then use the caret, and in parentheses do 1 divided by 4. And then close the parentheses. And this doesn't work out evenly. The exact answer would be the 4th root of 3,000. or approximately 7.4. For b, first we have to isolate our power. We have to divide by 6 on both sides. X, and now instead of looking at this exponent as a decimal, I want it as a fraction. 5/2 equals 15. And by looking at this as a fraction, I can think about what exponent would I put out here, would I multiply 5/2 by to cancel it out? 2/5. That leaves me with x equals, again, 15 raised to the 2/5 in parentheses. That does not give us an exact answer, but it approximately gives us 2.95. But the helpful thing here is thinking about these powers as fractions, and we can get rid of the exponent by raising to the reciprocal of what we have. And there is the assignment for today.